that length not agree? That's negative 2 pi over 2. Negative means becoming this. So that's what it is. So maybe I'm on.
Okay, did you plot? Should look like those.
I was right.
So, do you guys have any questions with how to plot any of these polar coordinates? No?
Oh yeah, you trying to get
Excellent. Now, second thing in pre-cal, you learned that if this is r and this is theta, then you learned that this side was just y, right? In terms of rectangular coordinates, and this is x. So this point can be listed as x comma y in rectangular coordinates, or if you're doing polar coordinates, it's r comma theta, right? And to convert that point backwards and forwards, then we'll use these conversions. So cosine of this angle is what? X over r, good. Sine of that angle is y over r, and tangent of that angle is y over x. Okay, so if we want to convert polars to rectangular, we should get x equals and y equals equations. So x equals r cosine theta. If you're in physics, I think you use those formulas a lot, right? And y equals r sine theta. They're like part of your vectors, like I, j, r cosine theta, r sine theta, i's and j's. Okay, we also know that x squared plus y squared equals r squared. So r is equal to plus or minus square root x squared plus y squared. But there's so many ways to define r and theta. There's only one way to define this point in terms of x and y. But there's so many, there's like a million different ways to identify this point in terms of r's and thetas, right? So you could have a negative r, but the theta and the theta down here to go backwards. You could have a positive r and a theta here. You could have a theta that has like 2 pi added to it, or a negative theta. But so many different ways. So these two things, when you're converting, you'll just have to be careful of for the tangent and the R1. Okay, we're going to start with polars, and we're going to convert them to rectangular coordinates. Rectangular is x comma y. So we're going to use these two formulas, x equals r cosine theta and y equals r sine theta. That's how to convert to rectangular. So x equals r cosine theta. R is 2 cosine of 5 pi over 6. So cosine of 5 pi over 6 is positive or negative? And then simplify, negative root 3. So, and y equals r sine theta, which is 2 sine of 5 pi over 6, 2 times positive 1/2. And so that's 1. Okay. So, on a graph, these are like kind of important to recognize. On a graph, like the 2 comma 5 pi over 6 is like right here, right? Out to over an angle of 5 pi over 6, right? So our thing is out to, and then we have an angle of 5 pi over 6. But in rectangular, basically what we did was we found that x was negative root 3 and y was 1, and that's the same exact point, but in rectangular coordinates instead of polar coordinates. Okay? Are you with me? Cool. Let's do this one. 3 comma negative 3, and we want to convert it to r and theta. So I'm going to use these two formulas. Tangent theta is y over x, and r equals plus or minus square root x squared plus y squared. So 3 squared plus negative 3 squared equals r squared. So we get 9 plus 9, which is 18. Square root both sides. So we get 3 root 2, right? Equals r. And then to figure out theta, we'll use the tangent theta because we have y's and x's. So tangent theta is negative 3 over 3. So when is tangent negative 1? Negative pi over 4, also 7 pi over 4. There's a million, right? Okay, so on our graph, we want to hit 3, negative 3 as our x and y coordinates. So what should my theta be? Yeah, either one actually works. So you could say negative pi over 4, or you could say 7 pi over 4. So this coordinate would be 3 root 2 comma negative pi over 4, or 3 root 2 comma 7 pi over 4, or you could also do negative 3 root 2 comma 3 pi over 4, right? I know, but they're all options. Okay? Not too bad so far. This is just review. So, yes, Mia? All the way to the bottom? Yeah. Polar's okay so far? All right. On to conversions. You don't have to do this much in calc, but if we wanted to convert y equals 4 to polar form, then what would we do? Oh, we would replace our y with r sine theta. And then they usually like you to solve for r or r squared, but you don't always have to.
What are the circumstances where you have to?
If they say, find r of theta, you know what I mean? Like they would say, find like r of theta. So that means that they want r equals something with theta only in it. That's the specific instance. Okay, x squared plus y squared equals 25. That one's,
R equals 5.
yeah. That's just a polar with a radius of 5 all the way around. Because it's a circle. Okay, r sine theta equals 3. Anybody? Oh, we're going to rectangular this time. Y equals 3. So this is just a straight line at 3. For this one, does anyone know what it looks like in polar form?
Is it flowers?
You're close. It's kind of a flower, but it's not. because there's no number next to the theta. So what is it? Do you guys remember what it is if there's no number next to the theta? It's just a circle. So like a flower with only one petal or a rose with only one petal is just a circle. So this is a circle on the x-axis with a diameter of 2 or a radius of 1. So it's like it's a flower with one petal, a rose with one petal, but it's the petal length is 1, but it's a nice circle. This is a nice circle. Good job. Thanks. All right, how do you convert it though to rectangular form? You multiply both sides by r. Okay, so this would make this r squared equals 2r cosine theta. And now I have things that I can replace. So what can I do? R squared is x squared plus y squared. And r cosine theta is x. So we have 2x here. And then what do we do?
Put the x's on one side.
Okay, so brought everything over to one side. What do you think we're going to do? Exactly. So we're going to complete the square. What should I add to that to get it to be a perfect square? Yeah, remember you take the middle number, divide it by 2, and square it. We're going to add 1. And if we add 1 to that side, I have to add 1 to my other side of my equal sign. So this becomes x minus 1 squared plus y squared equals 1, which is the exact same equation as this. It's a circle centered at 1, 0 with a radius of 1, right? Okay, are we still okay? Now, theta equals 2 pi over 3. Let's tangent both sides. What's tangent of 2 pi over 3? Negative. Oops. Yeah. And tangent of theta can be written as y divided by x. That's how we can get that back to rectangular. So y equals negative root 3x. So this line that goes through 2 pi over 3 has a slope of negative root 3x. No, because r can be negative. So this is for every r value. For every r value, if r is positive, it's going to keep going out this way. If r is negative, it will go backwards, right? So if you plug in negative r's and positive r's, it'll give you the equation of that whole line. Okay. Now, there's 2 different things that they'll ask you for polars. The first thing is they'll ask you just for the rate of change, like r d theta sometimes. This is not equal to the slope of the tangent line. Okay, so don't make that mistake. If they ask you to take to find dy dx, don't just take the derivative of your polar, because dy dx is in completely different variables than your polar equation. So, to find dy dx, you have to take the derivative of y with respect to theta over the derivative of x with respect to theta. What does that mean? That means that you gotta take these original equations, y equals r sine theta, and you have to take the derivative of them. So what's dy d theta will equal r times cosine theta plus r prime sine theta. What? No, it's a variable. And then x equals r cosine theta. So dx d theta is r sine theta negative. Oh, darn it. Can you erase this? It's better this way. Take the derivative of r first. So that the minus is in the middle for the dx d theta. Okay? And then that's what this would be. R. I suggest it is dx d theta.
Did you write r prime as dr d theta?
You can, but I just do r prime because it makes it. It's supposed to be dr d theta, but for the formula, it's easier to just write it as r prime. Okay.
Should we memorize it?
Well, I don't. I just take the derivative every time of y and x. Because in the same time that it takes to like do that, I could just write these two out, and then put them over each other. So, if you want to memorize it, you can, but you don't have to. Okay. For this example, dy dx is that, we want to find the slope of the graph of the polar curve for r equals 3 plus 2 sine theta at pi over 6. Do you remember how to graph 3 plus 2 sine theta also, by the way? Okay. You're going to have to, because guess what we're doing next class? We're finding the area of these polar things.
Do I have to re-memorize all of these?
You don't have to memorize them, but you do have to know that these make versions of limaçons. So, in order to graph these, you just need to find the 4 axes points. So, if I plug in 0 in here, what does that equal? So if I plug in 0, what does r equal? 3. Okay, so at 0 degrees, I go out 3. At pi over 2, plug in pi over 2. My answer is, my r is 5. So I go up 5. At pi, plug in pi, my r is still 3, right? Uno, dos, tres. And at 3 pi over 2, my r is at one, right? 3 minus 2. Okay, if you get any negative values, like if this was a -1 and it ended up being here, then it would be a limaçon with a loop, right? If they're on the same axis. But since it's not here, and it's like they each have their own axes, then we have no loops, and it's just a straight up corgi butt. Okay. So we're trying to find at this pi over 6 right here angle, we're trying to find the equation of, or the slope of this tangent line right here. That's essentially what we're trying to do. But we're trying to find it in terms of x and y, not r and theta. Because we don't want to know how it's changing, how the angle is changing with respect to r. We need to know just the slope of the tangent line. So here's what I like to do. I like to figure out each of the 4 components. I like to figure out r, at pi over 6. So sine of pi over 6 is 1/2. 3 plus 1 is 4. So my r is 4, right? I like to figure out r prime. What's the derivative of 3 plus 2 sine theta? 2 cosine, and we can plug in pi over 6. So 2 times cosine of pi over 6 is just √3, right? And then I also like to write sine of pi over 6. You don't have to do this. And cosine of pi over 6. Because sometimes it makes it easier when you're plugging these into your derivative, your dy dx. You have all the components already made, since there's so many parts. So it's it's √3 times sine, which is 1/2, plus r, which is 4, and cosine is √3 over 2, all over r prime, which is √3. Cosine theta is √3 over 2. R is 4. Oh, it should be a minus, guys. And 1/2, right? Okay. It's not too bad. All of them are divisible by 2, so I'm just going to cancel out the 2 from everything. So I just have √3 plus 4√3 all over √3 times √3 is just 3 minus 4. So my answer is -5√3 is my slope of my tangent line. Questions? All right. What's the next page? Oops. Okay, we're not going to do area yet. Don't want to scare you. But I do want to go over how to graph things. Like, So this is what we're talking about, the limaçons. All of these have the formula R equals A plus or minus B sine theta, or R equals A plus or minus B cosine theta. And if it's sine, it's gonna sit on the y-axis. The big part of it is gonna sit on the y-axis, and if it's cosine, the big butt is gonna sit on the x-axis. It looks like a butt to me. Okay, now roses, you don't have to memorize these things, because if you just calculate all four coordinate axes, then you'll see which one it is anyways. The roses, do you remember things that are special about that? Yeah, so if n is even, because it's either a cosine theta n theta or a sine n theta, right? So if n is even, then how many petals do you have? No, you just have the same number of petals. No, you have double petals. If n is even, you double the amount of petals. If n is odd, then you have just same number of petals. But your period, this is important, is only pi, because you end up repeating if you do if you do too many polars. R equals 3 sine 3 theta. Okay, so see how this is 3 sine 3 theta, and it says, you can't see it here, but this is a period of 0 to pi. So it graphs like that. But if you go to 2 pi, it looks looks exactly the same, but really you're overlapping it twice. Now the problem, it doesn't really matter, but the problem is when you're finding area and you're overlapping your graph twice, then you're finding double the area than you need. So this is why it's important to know that, like, where it stops. Okay. Then remember how I said, roses with only one petal are circles. So R equals A cosine theta or R equals A sine theta are circles with one, roses with one petal. And then these are the equations of the lemniscates, the peanuts. Okay, so you should know how to graph those. Okay, we're not gonna do area today. But I have something that I want you to do. And we're not going to do this whole worksheet. But it's good practice. It has like 3 parts to each one. do the first one together, and then I'm gonna let you work on the second one on your own. But these are very, very similar to free responses that you'll get on the test. So that's why I want to work on them together. And also, they're really good questions if you want extra practice as to what I'll ask you. So let's do the first one. You can do it on a separate sheet of paper, or you can do it like insert it somewhere in there. Okay, I don't have a calculator on here, so I'm just gonna tell you what to do, but hopefully you have do you have your calculators out? Grab your calculator, because most of the time you'll need it. Maybe I'll try to get one up.
You have to go to
I'll try to pull a calculator up.
I didn't do that.
Yeah, that's why we have to go through them, because it's like weird looking. I'm sorry, give me a second, guys. Okay, I can't pull it up, but I'll tell you what to do on your calculator. Alright, so we need to find the points of, or maybe we don't even need our calculator, but we'll try it. We'll see. No, do not change your mode to polar mode, because I'm going to tell you right now, you can't find any intersections in polar mode. So if you try doing anything in polar mode, it's a bad idea. No, you don't convert it. Just like pretend R is Y and X is, you know what I mean? If you're ever trying to solve for something, just keep them as Y's and X's, even though they're R's and thetas. I'll show you in a minute. Anyways, we need to find these two intersections, right? So go, how do we find intersections? We set them equal to each other, right? Now it's going to look strange to you, but what I want you to do is, see how we have our equation here? In your calculator, I want you to type this one in Y1, don't change it to polar, and type this one into Y2, and make sure your window is set at 0, 0 as your x min and pi over 2 as your x max.
X instead of theta.
Yes, do x instead of theta. We just need intersections, so we don't need it in polar mode in order to calculate the intersections.
Should we make that y? No, for that window.
So they would intersect with the same points. I mean,
Yeah,
it's the same
exactly, right? So we're solving it in,
points. Wait, but it's not in.
it's not in polar mode, you're not going to be able to see it, but it's,
not in rectangular form. Aren't they different?
no, because you're still solving an equation. So it doesn't matter. This equation is still being solved. Like x is going to equal whatever, and x is just theta. Okay. So what did you get for your 2 points of intersection? Did you find them for me?
Point 17.
0.175, and what's the other one? 0.873?
Mine's showing just like
Are you in degree mode?
oh, I am.
That usually fixes it when it just shows straight up line. Okay, everybody okay with that?
We don't need to solve.
So, yeah, we could, but I want you. There's questions on the test that you won't be able to, so I want to show you the way to do it. Okay, now it says write your answers using polar coordinates. So that means r comma theta. R is 3, right? So it's 3 comma 0.175 and 3 comma 0.873. We could have solved this by hand, but I do want to practice calculator with you. Okay, so that's part A. Part A is done. Now it says write the coordinates of the points of intersection using rectangular coordinates. So I have the polar ones. Now all I have to do is convert them to rectangular. So x equals r cosine theta.
Are we supposed to like save those values as variables in that?
Yes. And y is r sine theta. Remember, if you found the intersection, it should be stored in for x for you. I'm gonna need your help, guys, with this.
Can we only do it for 0.175?
No, we're gonna do it for both. So
What the value of that? Probably for that value.
okay, I got it. Sorry. All right, I think I can do it. You don't. I'm just trying to show you there's things that you will have to do. So I'm using this as an example to give you like, hey, if you couldn't find it by hand, this is how you would do it. Because a lot of people go into polar mode and they shouldn't. 5. This is the other one. So I'm going to do the other one first. Ugh. 3 cosine x, 3 sine x. So 1.928. What's the other one? 2.298. And did somebody figure out the other one for me? Okay, maybe not. What did you say, TJ?
Wait,
0.521? Thanks. So there's our other one.
Yeah, I have 2.9.
That makes sense because, like, see, this point is like a little bit more than, I guess, like 2.9 and 1.52. So that's right. Okay, now, this one says, part C, find dr d theta, interpret the meaning of your answer in the context of this problem. So, part C, they do this a lot, so pay attention. Dr d theta is going to equal, okay, so we just take the derivative of 6 sine 3 theta. What is that? 6 cosine, right? 3 theta times 3, or 18 cosine 3 theta, right? So we found dr d theta. Now we're going to plug in pi over 4. So 18 cosine of 3 pi over 4. Well, cosine of 3 pi over 4 is negative root 2 over 2, right? So we get negative 9 root 2. Are you with me?
yeah.
Okay, now the interpretation is that as theta increases at pi over 4, r is doing what? Decreases at a rate of negative 9 root 2, or at a rate of 9 root 2. I don't know if you need the negative. I don't think they'd penalize you if it was like a double negative, but it's better if you just say r decreases at a rate of 9 root 2. Or you can say r, this is one option, or you can say r is getting closer to the origin. Does that make sense to you as well?
You have to say at pi over.
Yes. And then you have to continue, you have to finish it. But like, instead of saying r decreases at a rate of, like, another idea is r is getting closer to the origin. Because if r is decreasing, it's getting closer to the origin. Okay, still with me? Kind of? Maybe not. Ish. We'll do more of these, but they're good. They're really good for you to see what should be asked. Okay, next part. For theta from 0 to pi over 2, there are 2 points on R1 with an x-coordinate of 4. So we're really looking at these 2 points on R1 that have an x-coordinate of 4. Do you see it? Find the subject points. Express your answers using polar coordinates. Okay. So we know x equals 4. And we need to figure out the points, the polar points. So what is x equal? Rows. So r cosine theta equals 4. Now we have the red curve. The red curve is 6 sine 3 theta, so that's what r is, so that's going to get plugged into this r. Cosine theta equals 4. Okay. See, in this instance, if you were in polar mode, you wouldn't be able to solve it. So in rectangular mode, you go and type this one in y1 and type this one in y2, and you can figure out what theta is going to be.
Is the only way to solve this for a calculator?
Yes. So 6 sine 3 theta times cosine theta, and y2 is 4 this time. But we still just want the interval 0 to pi over 2, the window. And if we did it right, there should be 2 places. There are. Because the question said pi over 2. Okay. .253. Is this overwhelming? At this theta, I'm gonna just calculate my r since I'm here. Six sine 3x. 4.132. And then I have another theta. I have to see.
Wait, and you just did that putting the theta to r cosine theta equals 4.
Whoa, 15 people asked me questions.
So where'd you plug it in? You plugged in the theta to the r cosine theta equals 4.
I plugged it into 6.96. Hold on.
Where'd you plug in the theta to get the r value?
Hold on. So this is my other intersection. I plugged it into r. 6 sine 3x.
Oh, okay.
Because that's what r is equal to. 5.213. But it's better to have the intersections and get them exactly right. Okay, so 0.253 and 4.132 and 0.696 and 5.213. Those are my
Where'd you plug it back into?
r.
Oh. Okay, so
Because it's 6 sine 3 theta. So now that I know the thetas, I can plug it into 6 sine 3 theta to get r.
and then where the cosine theta come from?
The cosine theta is because this is where x is equal to 4, and remember x is the equation r cosine theta. I think we're only going to be able to get through one problem, guys. This is some tricky stuff. What?
Wait, so for the polar coordinates, isn't the r come first?
You're right. Thank you.
Okay, I would just.
Yes.
Thank you. But that's the annoying thing is usually you solve for theta first. I've actually looked it up and I was like, why does theta come before r? Because usually you go to the angle and then you go out that direction. They didn't have a good answer for me.
Convention.
Yeah, convention. That's their answer. That's their answer for anything that doesn't make sense.
Instead of having 12 stages,
True, true. Next one, E,
I don't want to think of.
dy dx. Okay. Now remember, which one are we doing it with? R1? Okay, with R1. So remember, dy dx is, oh geez, r prime sine theta plus r cosine theta over r prime cosine theta minus r sine theta. What's the r prime? Did we figure that out already? What's the derivative of 6 sine 3 theta? No, we did. It's 18 cosine 3 theta. Not too hard to do again, though. Sine theta plus r is 6 sine 3 theta cosine theta. R prime is okay. Well, that's our expression. We're done. Write it in terms of theta, an expression. That's it. We did that. Okay. Now we need a tangent line at pi over 4. So now that's done. Now we plug in pi over 4. So our dy dx is going to equal 18 cosine 3 pi over 4 is negative 18 root 2 over 2. Sine of 3 pi over 4 is root 2 over 2. 6 sine of 3 pi over 4 is still root 2 over 2. Cosine of pi over 4 is root 2 over 2. All over. Oi! This was not a nice ease into polars for you guys, was it?
Very brutal.
What does the numerator say? 6 times what?
I thought polars was just gonna be like converting and then graphing, not like that.
Well, there's so many root 2's in everything, we can cancel them. Negative 18 plus 6. Negative 12. Over. Negative 18. Oh, yeah, I can just cross out. Wait.
What are you trying to get across out?
No, negative 18 minus 6.
Wait, minus 1/2.
Yeah, negative 18 minus 6. Hey! That's nice. Alright, we're almost done, guys.
Oh yeah, now we gotta write an equation.
So I need y,
Right now.
1/2, x. But we need x and y. Well, x is
Did we do this?
r cosine theta, and y is r sine theta. What is r? R is 6 root 2 over 2.
Where do we find that? 6 cosine.
I found it here. Because that's r, right?
Oh.
And then cosine of theta is, and sine of theta is $18
Yeah.
So 3 and 3.
over 4.
We have 3.
6 times 2, right? Or no, 6 times 2 is 12. 12 over 4. 6 times
Can you just make this?
root 2 times root 2 is 2. 2 times 6.
It's 3.
Over 4. Isn't it
Yeah, 3.
They're both. Probably.
Such a nice answer for all this ugly work that we did.
Probably a lot of work.
Why is it plus? Why is it plus?
Oh, I don't know. You do whatever you want to do.
I'm gonna quote you on that next time I get something wrong. I did what I wanted to do.
I was mandated by higher ups.
Yeah, higher ups.
Oh, that was fun.
Okay. Well,
I like that one.
are you ready to do this on your own?
No.
We don't really have that much time.
No, this goes through F, but it's the good thing is they all ask the same things. So once you conquer, if you conquer this worksheet, you're never going to have unexpected polars types questions.
Can we cover the second part of the worksheet in class next time?
Yes, we'll do, save this worksheet. We'll do number 2 and maybe number 3 next time, but we also have to do area polars. I might actually we might actually do 3 days of polars.
Instead of.
We're just gonna do 2 days of test.
We're just gonna do 2 days.
It's good to have plastic good.
Yeah, because because we have to do area, and area is going to take a while too.
Calculus.
Those 2 sections, I might only do 1 day of. We might spend more time on polars and less time on the other stuff.